Alright, this is video 1.5. Today we're going to be reviewing the properties of exponents. First off, just remember that exponents and powers, you've got your big number, which would be your base, and then your little number, which would be your exponent. And what this means is that you've got your base multiplied by itself your exponential time. So 2 to the third power would be 2 times 2 times 2. All right, so let's do some practicing. When they are written this way with in a parentheses, then everything in the parentheses is the base. So to write this in expanded form would be 4y times 4y times 4y. If it is not included in the parentheses, then it is not included in the exponent. So in this case, our negative here in front of this a is not included in the exponent, so it's going to go on the outside, and it would be a times a. If it were included, it would look like this. In that case, it would be negative a times negative a. And this is important, you can see, especially if you have an even power, because this answer right here, whatever a is, you're going to have a negative answer. This one would give you a positive answer because you would have a negative times a negative, which is going to give you a positive. So it's important to know whether or not your negative is squared or it's not squared. And when you're typing it in your calculator, you also have to be very careful. If it is in parentheses in your problem, when you type it in your calculator, make sure you keep it in parentheses. If it is not in parentheses, you write it just exactly like it is, and your calculator will help you come to the right answer. All right, this next one in expanded form, this is not raised to this third power here. So what this would be, we're going to break it all apart. So our 2 has no power, so it's just going to be a 2. Our y is squared, so it would be y times y. And then our x minus 3 is raised to a power, so we would do x minus 3, x minus 3, x minus 3. A couple of properties that you need to keep in mind. Go ahead and memorize these. Anything raised to a 0 is going to be equal to 1. So for example, if you had 100 raised to the 0 power, that is a 1. If you had a billion raised to the 0 power, it is a 1. Okay, anything raised to a 0 is going to be a 1. And the negative exponent property just says that anything that you have, if it's raised to a negative exponent, then in order to make that negative exponent a positive exponent, you're going to have to take the reciprocal of the base. So if we had 7 to the negative halves, or negative square, negative halves, in order to have our negative 2 be a positive, we're going to take our 1/7, which is the reciprocal of 7, and then raise the 7 to the second power. If it is in fraction form, like here, you have 3 halves raised to the negative 4, then the reciprocal is going to be 2/3, and then we'll just keep our 4 up there on the top because it applies to everything that is in parentheses. So let's practice using those to simplify a couple of expressions. This first one here, how would you simplify that? So we're going to take our whole expression and drop it down to the denominator. So that would be 1 over 2 cubed. Further simplifying that, 2 cubed is 8, so that would be 1/8. And this one. Okay, so remember our negative is going to stay out in front. So the negative is going to go in front. I'm going to take the reciprocal of my fraction, which will be 4/3. All that is raised to the 4th power. So my negative is going to stay in front. 4 to the 4th power is 256. 3 to the 4th power is 81. And then if you want to, that answer is completely fine to leave it as an improper fraction, or you can turn it into a mixed number, which would be negative 3 and 13, 81. Other properties of exponents. So if you have two two things that have the same base and you're multiplying them, then you add the exponent. So if you have 3x squared, sorry, let me get rid of the 3. If you have x squared times x to the 4th, you're multiplying them. They both have an x as a base. The exponents aren't the same, but that's okay. Exponents only have to be the same if you're combining like terms by adding and subtracting. When you're multiplying them, you can multiply. So you're going to keep your x and you're going to add your exponents, which would be x to the 6th. So the reason behind that is if you write them out in expanded form, our x squared would be x times x, right? And then we have our times, and then we have x to the 4th, which would be x times x times x times x. If we were going to write that back down instead of being expanded and simplify it, we have 1, 2, 3, 4, 5, 6 x's, which is x to the 6th. The quotient of powers, if you are dividing powers with the same base, you're going to subtract the exponents. That can be written like x to the 4th divided by x squared, in which case you would do 4 minus 2, which is x squared. Or if it's written this way, x to the 4th divided by x squared, that would be x squared is the answer when you subtract them. Power of a power, if you have a power raised to another power like x squared cubed, then you're going to multiply these. So it's easy to get confused between this one and this one. So when they're like this, you add. When they're like this, you multiply. So this would be x to the 6th. And the power of a product. So to find the power of a product, you're going to apply the exponent to each factor. Okay, so if we had like say 3 times 4 and the whole thing was squared, we can, especially if they are letters and it's a little harder to do, it would be the same thing as saying 3 squared times 4 squared. So with letters, let's say you had xy squared, that would be x squared y squared. And then the power of a quotient, to find the power of a quotient, you're going to apply the exponent to the numerator and the denominator. So with numbers, let's say it was 3/5 squared. You could say this is 3 squared divided by 5 squared, or 9 divided by 25. So with letters, let's say we had x and y squared, then that would be the same thing as x squared over y squared. So you apply it to each, there and there. So let's use those properties and simplify a couple of expressions. Okay, so first off, right here, we are going to multiply this term by this term. So our coefficients multiply, so it'll be the 2 times the -5, which is going to give us -10. And then our x's are going to multiply. Because I am multiplying an x times an x, I'm going to add the exponents, which would be x to the 4th. So the next one here, we've got a couple of things going on. So first thing I'm going to do is I'm going to distribute my, my 2. I'm going to distribute it here, distribute it there, and distribute it there. Right, so I'll have a squared, and then b to the 4th to the 2nd is going to be b to the 8th divided by b to the 14th. Now I have a common base, so I can subtract those. Now I'm going to have a big minus a little, and if I did 8 minus 4, I'm sorry, a little minus a big. If I did 8 minus 14, I would end up with a negative exponent. The easiest thing to do, because you can't have a negative exponent, you want to have positive exponents, so that b is going to stay down in the denominator anyway. So I'm going to do the difference between them, and I'm going to leave it in the denominator where the bigger exponent was. So my a squared stays here, and then my 8 minus my 14 is 6, so I'm going to leave that down in the bottom. Now, I just want to show you that you can get the same thing if you did the subtraction first. So let's, on this side, I'm going to show you, I'm going to subtract my b's before I raise them to the power. So I have a b to the 4th over b to the 7th squared. I'm going to go ahead and reduce those down. I'm going to leave that b on the bottom to start here. So I'm going to say 4 minus 7 is going to be b cubed raised to the 2nd power would be a squared over b to the 6th. Let's do it if we didn't have our cube on the bottom and we said 4 minus 7 and put it on top. So that would be an a. 4 minus 7 would be to the negative 3 raised to the 2nd power. That would be a squared, b to the negative 6. My negative 6, I'm going to put it down in the basement in the denominator in order to make it positive, which would be a squared over b to the 6th. Any of the ways you want to do it, you're probably going to end up with the same answer. Let's practice one more. I'm going to erase those so that I have plenty of room. All right, here I'm going to distribute my negative 3 first. And then after I do that, then I will make it positive by putting it in the denominator. That's how I'm going to choose to do it first. So negative 2 to the 3rd power is going to be a negative 8. Because negative 2 times negative 2 is going to give me a 4. 4 times negative 2 is going to give me a negative 8. I'll do my a to the cube, so I'm going to multiply my 3 times negative 3, which is going to give me a negative 9, and b to the negative 3rd, so that would be b negative 3. And now, in order to make my two exponents here positive, I'm going to do the reciprocal, so it would be 1 over negative 8, a to the 9th power, b cubed. All right, scientific notation is just another example of using powers. It is using the powers of 10. So when you're doing this, if it's a positive exponent here, then you move your decimal to the right. Think of this as being a really big number. It's a positive. It's really big. So we're going to move it, the decimal, from this spot. In scientific notation, that's pretty much where we were aiming for our decimal to go, is after the very first number. We want a number and then a decimal, and then everything else goes after it. So however many digits are in the scientific notation that you're given, you're going to add that many more zeros until you have a total of 7 that you've moved it. So I'm going to go ahead and keep my 1, and that does not count towards the 7 that I'm going for. So I'm going to move my decimal. I'm going to move it 1, 2, 3, 4, 5, 6, 7. Now I'm going to go in and put my commas. So this is just another way of writing 12,750,000. Now, if your exponent is negative, then that is a very small number, and we are going to move the decimal this way. And we're going to move it a total of 7 times. So our 5, while we're going to include it, does not count towards that 7, but the 3 does, because we are going to move the decimal that direction. So we are going to move it 1, 2, 3, 4, 5, 6, 7, and put our decimal. Okay, so this number right here should match that, and on this side, those numbers should match your exponent. And likewise, if you are going from a number, let's say, let me just write one out here, and we were wanting to write it in scientific notation, this is where our decimal is at. This is where we want our decimal to be. So I'm going to keep all my significant digits here. So I'm going to do 1.37. I'll have my times 10. This is a big number, so I'm going to have a positive exponent. Now I've got to figure out what my exponent is by counting. I moved it 1, 2, 3, 4, 5, 6, 7, 8 places. So it's going to be a positive 8 because it's a big number. If I'm given a very small number, then I know my exponent is going to be negative. Right? Here's where I want my decimal to be, so my significant digits are going to be 1.25. Now I count them. 1, 2, 3, 4, 5, 6, 7. So it'd be to the negative 7. We don't count the 2 and the 5 because the decimal didn't go past them. So let's use some of our scientific notation to simplify some expressions. When you have them like this and they're already in scientific notation, the easiest thing to do, we're just going to split it in half. We're going to take care of this part and then take care of that part. So 9.1 divided by 1.3 is 7. Okay, or 7.0 if we're keeping our significant digits. We have a tenths place, so we're going to keep our tenths place. Times 10, now we take these. We have a negative 3 minus an 8. It's going to give us negative 11. So if we were to write this in expanded form, we would have 10 zeros before that 7. That's the same thing as saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now if we're multiplying, it's going to be the same thing. I'm going to take these and then I'll take those. So 3.5 times 5.2 is going to give me 18.2. Keep my times 10. Now my tens, my base stays the same. I add my exponent, so I'm looking for 8 plus 5, which is 14. So this would look like, not counting those, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that is a very big number, right? That's it for today. It's kind of a long video. Hopefully you remember all the powers of exponents, and I'll see you in class when you come. Have a good afternoon.